Welcome to Spring LIB.
Okay, so we need to write MCQ, all right, to make you understand about the velocity and acceleration. So let me begin with the question in red. Two robots R1 and R2 start from the same point or same line for a race. R1 starts from rest with acceleration 20 meters per second squared. R2 starts with initial velocity of 10 meters per second with acceleration 10 meters per second squared. Which robot will win the 100-meter race? So options are robot R1, R2, tie, that is they reach the same time, and D, information insufficient. Okay, so to do this, it's seen that the R2, the robot R2 has a higher initial velocity but lower acceleration, whereas R1 has a zero initial velocity but it has higher acceleration. So let's see which one wins. So to do this, let's write the values of S, the distance traveled S for R1. This one is for R1. The distance traveled should be the same for both, for R1 as well as R2. The initial velocity for R1 is uh, 0, right? The final velocity, sorry, the acceleration A is 20 meters per second square, and for R2 the initial velocity is 10 meters per second, but the acceleration is 10 meters per second square. Uh, it seems like the R2 has higher velocity and should reach faster, right? But let's see what happens. So using the equation of motion, S is equal to ut plus half at squared. So just plug this in here. So 100 is equal to 0 plus half a, that is 10. t squared. So this gives me t is equal to root under 10, that is only 3.16 seconds. So this is the time taken for R1. Similarly, the time taken for R2 is S is 100 is equal to ut means 10t plus half at squared means plus 5t squared. So solving this quadratic equation, you get t is equal to 3.58 seconds. Wow, so which one wins the race? So R1 wins the race, right? Because it takes shorter period of time to reach the 100 mark limit. And this shows that though you start at a lower velocity, if your acceleration is high, ultimately you will reach to a higher velocity, right? And you will win the race. So this is the solution to this problem.